Hi everyone. So yeah, in this video we want to talk about Michaelis-Menten plots, and today we want to talk about developing such plots so that we can experimentally derive some of the constants that we have been talking about, such as the decay constants in the reactions earlier. So of course we'll have this general Michaelis-Menten equations, and this is our Michaelis-Menten constant. This is our maximum rate. And if you followed the derivation videos, you'll know that V will have this relation with S, which is the substrate concentration, and this is the production rate of our desired product P. So depending on the rates, the way that we do the assumptions behind the kinetics, you'll have different forms of the equation, but generally you want to derive them in this sort of fashion. So okay, we want to linearize the plot, right? And yep, we want to linearize the plot. So what can we do? Well, we want to explore some of the ways in this video so that we can determine Vm and Km, which is the Michaelis-Menten constant. So okay, the first most direct way is we just invert this whole equation like so here, so that Km plus S is on top and Vm plus S is at the bottom, and you have 1 over V on the left hand side. So let's just we'll simplify the right hand side so that Km is over Vm plus S. Then you have this and that into this. This is a multiplication, yep. And the second term will be S over Vm into S. So the S will cancel out, and you just have 1 over Vm on the right hand side. Okay, so you'll have this kind of thing, this kind of relation, which is also called a double reciprocal plot. So you have Km over Vm, 1 over S, and the right hand side will be like so. And what do you get? You can plot experimental data of 1 over V versus 1 over S. So you will have this x and y axis. Well, 1 over V will be your y-axis, 1 over S will be the x-axis, and this will be your slope, and this will be your y-intercept, or 1 over V-intercept. So we have 1 over Vm here, okay, and then what next? 1 over Vm, and you'll have this as your slope. So assuming it's positive, of course, if not, the reaction won't actually go forward. So you have a positive sloping graph of 1 over V versus 1 over S, and you have some kind of experimental plots here. This is assuming, of course, it gets done nicely. Now, of course, you can extrapolate it this way, except data here doesn't really make much sense at all. Yeah, this is saying that well, if this is 0, if 1 over S here is 0, this is an infinitely big constant, infinitely big concentration, then suddenly this is 1 over S less than 0, which means the substrate concentration is negative. So the left hand side of the part of this graph doesn't really make much physical sense, only the right hand side. So you should only pay attention here. Okay? But of course, in terms of mathematics, you can extrapolate this so that this is 0, and yeah, you find the relations here somehow. Well, it depends. But what I'm saying here is that the left hand side doesn't really make much physical sense. So by and large, you should be able to ignore the left hand side. Okay, so that is one way. That is one way of linearizing the plot. Let's have this again. So yeah, this is just experimenting, what works, what doesn't. So what next? What next? Well, we got to make sure this time that this and this come out as separate variables. Okay, and all this, what we are plotting, must consist purely of experimental data in the form of this S and V, or some kind of combination of that sort. So okay, let's try that again. So we'll multiply everything by the bottom. Okay, so now we have to be really mindful what we are doing. Okay, we've got to be really mindful what we are doing. So now, what do we need to look out for? Since we can't have we can't quite have constants, in a sense that how do you put it? Yeah, we can't have this and this being in the same term. So what else can we do? Well, if we can divide this whole equation by s. Okay, so divided by s, and then this will be 1 over s, and this will be just the v. Okay, never mind. We have to expand this out first, right? Or rather, do it this way. Okay, so now this looks a little better. At least this and the v are separate, which it should be the case. So yeah, you cannot collect your s terms together, so this is what you do instead. So let's multiply this in. So if a v was the first term plus km v over s as your second term, that will equals to vm. Now it looks a lot better. At least this is a a linear plot. It looks like it's starting to look like a linear plot already. So let's just do this. Let's shift this to the right hand side. And there you go. You have this becoming your y-axis and this becoming your x-axis. So the other way is this. You have v equals vm for s over s plus km, and let's say we want to collect our s together. That means I want to factorize this. Combine both of these s terms into one term. So let's bring this to the left, multiply both sides by the denominator. So yeah, I'm trying to collect all the s terms together. So this is what I'm going to do. So your equation will be like so. So let's expand the left hand side. Okay. So the left hand side is expanded. And generally, let's have it this way. V km so you have this brought to the right hand side. Okay, so once you collected all these s together, you can bring this over. Okay. So what I've done is just I brought this to the brought this term to the right hand side. So I've effectively factorized S out and divide the whole equation by this. And then what happens is this. Okay, now let's do it this way. So let's do it one step at a time. Ln of this times this. So we can take ln both sides. You can take the logarithm of both sides. And so we have ln v over v plus ln of km equals ln of s. And then you can bring this to the right hand side, and you should see what we are able to plot pretty fairly quickly. Okay. Now, you're starting to have a little bit of a problem, okay, where we have this plotted on the left hand side, which actually includes our Vmax term. And so apparently this kind of a method doesn't quite work. Excuse me. Yeah. This kind of a method, yeah, it doesn't quite work. So what can we do about it? Well, if you're not going to use this method, I suggest maybe this collection of S terms together may not be actually that relevant.